Okay, so this is question 2 of the training. So Jacob is on a gallery of a lighthouse when he notices two ships in the distance. The first ship he sees has an angle of depression of 42 degrees, and the second ship he sees is at 75-degree angle of depression. The lighthouse is 30 meters tall and sits on a cliff that is 50 meters tall, as measured from sea level. See the following sketch, which represents the situation. How far apart are the two ships? So that's our ultimate goal, and this is the breakdown of it. So first determine the angles of depression in the sketch. Which angle represents the angle of depression of 42 degrees? The 42 degrees was the sight to the first ship, so I'm looking for the first ship, which is D. There's eye level and the straight line for eye level, which is E. So it's DAE. If you click on it, check answer. Well done. Step 2, which angle in the figure represents the angle of depression of 75 degrees? So 75 degrees was the angle of depression to the second ship. Right here, it's stated in the instructions. So then the second ship is from eye level down to where you're at, down to the second ship. So CAE. So we're looking for CAE or EAC. That's representing the same angle. So now you can state that angle EAC is congruent to angle ACB, and angle EAD is congruent to angle ADB by the blank. If you look at the eye level line and the line with the first ship, so eye level line and the line with the ships, that is indicated right here by these arrow marks or chevron marks to be parallel. So when so we have parallel lines, and then this brings in all of our alternate interior, alternate exterior corresponding angles. So EAC. So EAC is talking about this transversal. So EAC right here, and they're talking about ACB, which is right here. So notice they are within the parallel lines and they are on opposite sides of that transversal. So they are alternate interior angles. Which of the following ratios can you use with the given information to determine the length of BC? So if we notice the length of BC is right here within this triangle. So I'm going to ask myself, in this triangle, is it a right triangle? And as you can tell from angle B, it is. So then I'm going to ask myself, okay, BC, is it an angle or is it a side length? So side length is BC, so it is a side length. So then the next question is, there's two tools we can use to find side lengths. We have, okay, to find side lengths, we can use the Pythagorean theorem, or we can use trig functions. So I'm going to ask myself, what is required if I want to use the Pythagorean theorem? Well, we have to have two known side lengths. And what is required in order to find a side length with the trig function? We have to have one side length and one angle besides the 90-degree angle. So as I look through this triangle, I'm going to erase this. I'm going to look for the side length measures. We don't have BC because that's what we're looking for. We do not have the length of AC. So that eliminates the Pythagorean theorem because that only leaves one side length known. So trig function, one side length and one angle. So we have a side length of AB, which is a total length of 30 plus 50. So this is a total of 80. using the segment addition. So 30 plus 50 is total to 80. Now the other angle that we have besides the 90-degree angle is this 75-degree angle. So when I am asking myself, okay, I want to find side length BC, my perspective is from angles of 75 degrees. So when I look at this, the 80 is the opposite side length because it's directly across from the 75 degree. The side length across from the 90 is the hypotenuse, and that leaves BC as the adjacent. So why I want to know that is because I'm going to ask myself, what am I looking for? I'm looking for the length of BC, which is the adjacent side length. And then I have the opposite side length. So then the next question I ask myself is, which trig function has a ratio that includes the adjacent side length is what we're looking for, and the opposite side length, because that's what we have. So when we talk about that, is it sine, cosine, or tangent? Well, sine, going back to our mnemonic device, so, ka, toa, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and toa, tangent, is opposite over adjacent. So just because I listed these in different orders, that's okay. I wasn't looking for an order. I just wanted to know which one had the adjacent side length and the opposite side length, and that's tangent. So the tangent ratio would be tangent of 75 degrees is going to equal the opposite side length, which would be 80, divided by the adjacent side length, which I'm representing as A. So in this, it would be tangent of 75 degrees. And then it wants to find the length of BC rounded to the nearest tenth. So when I use this equation that I have set up, I'm going to notice that this A, what I'm looking for, is in the denominator. And I do not like working with my unknown that I'm looking for in the denominator. So I'm going to use the property, the reciprocal property of the reciprocal proportions, because ratios are proportions. So what that means is I can flip them. So I can instead write 1 divided by the tangent of 75 degrees. Now some of you might be saying, where did 1 come from? And that comes from the fact that tangent of 75 degrees is a number, and any number can be written as a fraction over 1, as that number divided by 1. So that is where this 1 came from right there. And then since I flipped this side, I would flip this side. So it would be A divided by 80. And then I can solve this. So I would have, since I'm dividing by 80, I would multiply 80 to both sides. So we would multiply both sides by 80. Multiply this side by 80, and A divided by 80 multiplied by 80, these, it would be written out like this, 80 times A divided by 80, this portion would be. So 80 divided by 80 reduces down to 1. Just so that you could see that better. So we would have 80 times 1 divided by the tangent of 75 degrees is going to equal A. So then come over to calculator, make sure it is in degrees. You type in 80, parentheses 1 divided by tangent of 80. 75 degrees. and it comes out to be 21.43. Wants this rounded to the nearest hundredth, so since this is a 5, I'm going to round this up to a 4, so 21.44. So A equals 21.44. So what is the length of BD rounded to the nearest hundredth? So BD is this total length right here. So we are going to use another similar technique. This time we are looking at triangle ACDB. And notice that we do again have a right triangle. We have one side length. This total out was 80. We don't have the hypotenuse side length, and we want to find the BD. So again, I can't use the Pythagorean theorem because I do not have two known side lengths, so I can use the trig function. So we're going to go through the same steps. So label it according to the angle that is given. We're given that angle D is 42 degrees, so we're going to use this angle as our perspective. So straight across from that angle is the opposite side length. Straight across from the 90-degree angle is the hypotenuse. Straight, and then this leaves this as the adjacent side length. So then again, I'm looking for side length BD, which is the adjacent. So I'm looking for, so I want the adjacent side length, and we have the opposite. So again, going back over the SOHCAHTOA, which trig function has ratios that include the adjacent side length and the opposite side length, because that's what we want and what we have. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we're going to set up the tangent again. So tangent of 42 degrees is going to equal the opposite side length, which is 80, divided by the adjacent side length, which is representing our BD. So again, we're going to use the reciprocal property of proportion to flip these on their head. So we have 1 divided by tangent of 42 degrees is equal to A divided by 80. So again, since A is divided by 80, in order to move it on the other side, we're going to use our multiplication property and multiply both sides by 80. Multiply both sides by 80. So A divided by 80 times by 80, these would reduce down to a 1. And so then we would be left with our 80 times 1 divided by tangent of 42 degrees is equal to A. So I did the exact same process we did for the first section right here. So now we're going to type that into our calculator. 80 parentheses 1 divided by tangent of 42 degrees. Make sure it's in degrees. So 88.849 rounded to the nearest hundredth. Since that's a 9, this rounds the 4 up to a 5, 88.85. So then now it says, what is the distance between the two ships, or the length of CD? Well, we know this length to be 21.44, and we know our total length to be 80, what was it? 88.85. So to find our length of CD, we would take our total distance, which is 88.85, and subtract our length BC, which is 21.44. And what does that come out to be? So 88.85 minus 21.44, 67.41. There you have it.